Hello and welcome to Advanced Math, Vectors, Chapter 12, Homework Quiz on Part E, Recap Review. If you haven't taken that homework quiz yet, you should go ahead and do that. Or if you're not sure what's going on and you want to look at something before you do that, you can take a look at this as well. Question's different, but the method is similar. If you've already taken a quiz and you want to take another crack at it, well, this is the place to be. So the question on the original quiz, I think, was broken into two parts, and here I'm just sort of expressing it as one. Given 2 points in space, this is three-dimensional coordinates. A is at 5, 2, 3, and point B is at 7, negative 2, 7. We want to find the equation of the plane that's perpendicular to the segment AB. So if you imagine a line segment connecting point A and point B in space, and you want a plane that's perpendicular to that line, but not just any plane. You want the plane that's perpendicular to that line segment and passes through the point that's the midpoint of AB. So A and B on opposite sides of the plane, and the plane's right smack in between the middle of them. Sounds like an awful lot, but it's really not that bad. So the first step on doing this, knowing that you're going to want to get a plane equation, you're going to want to get a vector first that's perpendicular to the plane. Well, we have point A and point B, and we can use them as a model or the framework for a vector that would model that segment AB. So let's say we're going to find vector AB. And that would mean we want the vector that goes from A to B, or we could do vector BA. It doesn't really matter. Either one of them would be perpendicular to the plane. But vector AB means that we want a vector that goes from A to B. That means the components of this vector are going to be equal to the coordinates of B minus the coordinates of A. So the x-coordinates subtract them, the y-coordinates subtract them, and so forth. So it's going to be a B minus A. So the first component of vector AB is going to be 7 minus 5. The second one is going to be negative 2 minus 2, and the third one's going to be 7 minus 3. So finally, our vector components are going to be 2, comma, negative 4, comma, 4. So there's our vector that's perpendicular to the plane. All we need to do to get the plane equation, or get started with the plane equation, is take the components of that vector and use them as the coefficients of the plane equation. So here's our preliminary plane equation. Is going to be 2x minus 4y plus 4z equals d. We don't know what d is yet. The way to figure out what the d is to find a point that's on the plane and substitute its coordinates for x, y, and z in this equation. That'll give you d. Well, the point that we know is going to be the midpoint of AB. Whoa. So the midpoint, so work on that one. The midpoint of AB, well, there's a formula for that, but you know what? If you just think about each of the coordinates of these 2 points, the x-coordinates of A and B and the y-coordinates of A and B and the z-coordinates of A and B, the midpoint's x-coordinate is going to be midway between the x-coordinate of A and the x-coordinate of B. So finding a number that's midway between 5 and 7, well, you could picture 5 and 7 on a number line. You could probably pretty easily sort out what the number is that's right in between those two. The other more formal way of doing that is to say, what's the mean of 5 and 7, or what's the average of 5 and 7? So how do you do that? Well, you add 5 and 7 together and divide by 2. So 5 and 7 is 12, divided by 2 is 6. So the midpoint of AB, x-coordinate, is 6. Doing the same thing for the y-coordinate, 2 plus minus 2 is 0. 0 divided by 2 is 0, so that's 0 on the y-coordinate. And then the z-coordinate, 3 plus 7 is 10, divided by 2 is 5. So that's all you have to do to figure out the midpoint of AB. Okay, so now we've got the coordinates of a 3D point that's in this plane, and we have the beginnings of an equation for the plane. So we know that this point will work, or has to work, in this equation. And we can use that to figure out what D is. So let's substitute these coordinates in for x, y, and z and see what we get. So 2 times 6 minus 4 times 0 plus 4 times 5 equals 32. That's 12 plus 20, 32. So finally, we now have a value for D. We can write the full equation for the plane that satisfies all these conditions. That's going to be 2x minus 4y plus 4z equals 32. And that's all there is to it.